Hey, welcome back to school after your 4-day weekend. Hope you had a nice time at home. And I know it's been cold, so bundle up, which I'm sure everybody's already telling you to do. Wanted to go over a few problems with you, and give you a chance to try some things while I'm talking. So, pencil, paper would be good to have right now, and we're gonna just plow ahead here. So we're going to take a look at adding and subtracting problems that don't have the same denominator. I'm going to get my pen ready here. So you can see that the denominator here on the 9 and the 4, those are different. Okay. And that's fine. They can be different. I'm going to show you how to work with those in two ways to work with those that allow you to find common denominators so that you can add the numerators. So if we take 3 and a ninth, let's just set the 3 aside for a moment. I'm just going to circle that. And I'm going to circle the 2, so we're going to set that aside. We're just going to look at this as 1/9 and 1/4. You can write this down in your own paper right now. 1/9 and 1/4. So there's two ways to solve this. First, you could just simply multiply the 9 times 4 and get a new denominator of 36. It's perfectly fine. It works. And it's a tried and true method. The cons to this is that sometimes your denominator is huge. 36 is a pretty big number, but I think it's something that we can work with. So that's method number 1. Method number 2 would mean that you'd skip count until you get to a common number. So if you started skip counting, you'd skip count 9, 18, 27, and then 36, which we've already been kind of cheating a little bit, and we know that 36 works. If you were to skip count by 4s, 4, 8, 12, 16, 20, then 24, 28, 32, and finally 36. So method 2 is called the skip counting method. And it gets us to what we call a least common multiple. When you skip count, you're counting by multiples. And we want to find the least, so the smallest, common, the one that they both have, multiple, the number that we're skip counting by. So again, first method, multiply it out. Second method, least common multiple, also known as the LCM. Totally up to you as to which one you want to use, just as long as you know there's positives and negatives to each method. LCM, the negative might be is that it could be just confusing. But once you've practiced it, like anything, it gets better. So I'm going to change my color. I'm going to ask myself, 9 times some number gave me 36. Well, it's 9 times 4. And the weird part about it is the answer is right there. So that means 1 times that same number of 4 is going to be my new numerator. So my new fraction, I haven't made the quantity any bigger. I haven't done anything with, my dog Luna's with me, I haven't done anything with the quantity of making it like more or less. It's just the same. You're just taking that piece of pizza and cutting it into even smaller pieces. So 4 tiny pieces out of 36 would be the same as 1 larger piece out of 9. It's the same amount of pizza, the same amount of French silk pie or whatever you want to call it. And then down here, 4 times a number gave us 36. Well, the answer is right there. 4 times 9 gave you 36. Hi, Luna. And then we're going to use that 1 times 9 right here to give us 9. And then we can add 4 plus 9. Because remember, the operation here is addition. So just to plug in right here, we have 436. But remember, we set the 3 aside. So it's a 3 and 436 plus 2 and 936 give us our new answer of 3 plus 2 is 5, And 4 plus 9 is 13 over 36. Question would be is what would we do if our numerator was actually higher than our denominator? So let's say this is like 38 or 39 over 36. Well, you'd just like you would make trades in addition or subtraction or add, put in one on top or whatever, you'd have done the same there. You would have put, if it had been 39, 36, you'd have just said it ends up being 336 and then just put a 1 above the 5 and then make it a 6, 36. 6 and 336, if that makes sense. All right, looking at B, I want you to copy this problem down. 3/5 minus 1/7. And I want you to find that common denominator, either one of two ways. And then 8 and 16. Take a look at if you were to multiply, what that would do, or if you could look at the skip counting method, if that helps. So I want you to do both these problems right here on your own, and they're both subtraction. All right, so I'm going to scroll down. The question is, what is 3/4 of 60? Well, what's 1/2 of 60? It's 30, right? 3/4 gives us a clue. If we were to say to ourselves 1/2 of 60 is 30, well, half of a half is a quarter, so half of that half would be 15. That's one way to solve it. Or, so you could say that 3/4 of 60 is 45. I said that wrong, sorry, 45. If you were to take 60 and cut it in half, you'd have 30 here and 30 here. And if you were to take that and cut it in half, each of these would be 15 and 15. So if you have 3 parts out of 4, that's 45. You can draw it out. That works. Here's the mathematical way to solve it. Now this might make you kind of go 3/4 and 60. But remember, 60 is the same as having 60 over 1. It is the same. 60 is also 60 over 1. It's just another way of writing it. We're going to make this a multiplication problem. When you multiply, you get to go straight across. 3 times 60, well, 3 times 6 is 18. 3 times 60 would be 180. 4 times 1 is 4. So now you have to ask yourself, how many 4s fit into 180? Well, 4 times 10 is 40. 4 times 20 is 80. 4 times 30 is 120. 4 times 40 is 160. 4 times 5 is 200. That's too much. Half of 40 is 20. So if I get to that 160 level and I've had 40, and I go half of the 10, which is 5, I'm going to get 45. You might not have been able to follow my thinking on that, but if you think to yourself, 10 4s is 40, 20 4s is 60, or 80, 30 4s is 120, 40 4s is 160, 50 4s is 200. It's got to be between 160 and 180. Or I'm sorry, 160 and 200, which is 180. Okay. All right. 3/5 of 20. Well, if we were to take 20 and divide it into 5 pieces, you'd get 4, 4, 4, 4, and 4. 5 pieces, they're all equal. They're all 4s. Okay? Well, what's 3 out of those? Well, 4 and 4 and 4 gives you 12. In that crazy mathematical way that we just did, you could put 3/5. We haven't even talked about multiplying fractions. This is called the algorithm. 3 times 20 is 60. 5 times 1 is 5. How many 5s fit into 60? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. It's 12. Why don't you try that logic with right here, 2/3 of 18. See if you can give that a go and see if you can break 18 down into equal parts. Last one. Which is better? Which is a better buy? 12 cans for $9, or 4 cans for $3? Interesting question. So if I have 12 cans for $9, I know that if I cut that in half, I would have 6 cans for $4.50. 6 cans for $4.50. If I broke this down into thirds, so a third of 12 is 4, a third of 9 is 3. Well, hold on. A third of 12 is 4, and a third of 9 is 3. Hold on. I think I've discovered something that maybe we haven't talked about quite yet. It's the same kind of value. Which is the better buy? It wouldn't matter. You're going to get the same value. You might say to yourself, ooh, I'd rather have 12 cans, especially if someone else is paying for it. But in all reality, it's the same value. Okay. All right. That's what I wanted you to watch today. Hopefully you're able to solve some of these problems. Don't forget to go back and try 2/3 of 18 and the B and C here. I want to thank you for listening, and hopefully this helped you out a little bit. Have a great day.